Welcome to Study Loop.
Hello student, the given information is that P1 hat is equals to 0.93 and N1 is equals to 494. P2 hat is equals to 0.99 and N2 is equals to 344. And in A part, we have to construct the 99% confidence interval. So 100 into 1 minus alpha percent confidence interval for the difference between the population proportion, that is P1 minus P2, is given as P1 hat minus P2 hat plus minus Z alpha by 2 into under root of P1 hat into 1 minus P1 hat divided by N1 plus P2 hat into 1 minus P2 hat divided by N2. Now, first we have to find the value of alpha. The C is equals to 99%, that is 0.99, and we know that relation between the confidence level and the level of significance is equals to 1 minus alpha equals to C. Put the value of C, which is equals to 0.99, and after simplification we get value of alpha, which is equals to 0.01. So first, now find the value of Z alpha by 2, which is equals to Z 0.01 divided by 2, which is equals to Z 0.05. 0.005, which is equals to, by using a statistical table of the Z, we get this value as 2.58. How we find this value 0.005? The approximate Z value related with that value is 2.58. In this way we get Z alpha by 2. Now find P1 hat into 1 minus P1 hat divided by N1. P1 hat equals to 0.93, 1 minus P1 hat equals to 0.07 divided by N1 equals to 494. And after simplification we get this value as 0.00013. Now P2 hat into 1 minus P2 hat divided by N2, which is equals to P2 hat equals to 0.99 into 1 minus P2 hat equals to 0.01 divided by N2, 344. And after simplification we get this final value as 0.00028. Now find the margin of error. Margin of error is the term which is the critical value into standard error. So the critical value is 2.58 into under root of P1 hat into 1 minus P1 hat divided by N1, that is this 0.00013 plus this next term 0.00028, which is equals to 2.58 into under root of. This value is too much small, then approximate up to this point. Here is 8, then add 1 here. So now simplify it, we get this value as 0.00016, which is equals to 2.58 into under root of 0.00016 equals to 0.0126. After simplification we get margin of error equals to 0.0325. Now the formula for the lower confidence interval is equals to the P1 hat minus P2 hat minus margin of error, and the upper confidence interval equals to P1 hat minus P2 hat plus margin of error, and the all values are known, just put here. After simplification we get the lower confidence interval equals to 0.93 minus 0.99 minus 0.0325, which is equals to minus 0.0925, and here 0.93 minus 0.99 plus 0.0325, which is equals to minus 0.0275, and we have to round up this value up to the 2 decimal places. Therefore, the 99% confidence interval for the difference of the population proportion P1 minus P2 is minus 0.09. Here is the 2 which is less than 5, so have to write down 2 decimal places. Is the 7 which is greater than 5, then add 1 here, minus 0.03. This is the final confidence interval. Next, B part. is there a difference between the population proportion at 1% level of significance? And we know that if C is equals to 99%, that is 0.99, then it implies alpha equals to 0.01, which is equals to 1%, which is already calculated above. Look at here, 0.01, that is 1%, 0.99, that is the 99%. So we can apply in, we can using this confidence interval to find the solution. So from the given options, the option number 3 is the correct one. Yes, since the confidence interval does not include the value of 0, because the confidence interval is completely negative, so 0 is not belonging to that interval. So we can say that there is a difference between the population proportion. I hope this video is helpful for you. Thank you.